Hello and welcome to another edition of Science with Mrs. Blackburn. The last video posted was Drawing with Miss Blackburn, the Plate Tectonics edition, and this is going to be part 2 of that because that last video was a little long. These processes are kind of complicated, but we're going to make them simple. So today we're going to talk about convergent boundaries. Okay, so the last thing that we talked about were divergent plate boundaries. Now, if you'll remember, between the tectonic plates of the Earth, there's a lot that happens depending on how those plates move. Again, they can move apart, which would be divergent. They can move together, which would be convergent, and then they can go back and forth. That would be transform. So today we're going to be talking about the convergent plate boundaries when they move together and kind of one goes over top of the other. So the first one that we want to talk about is what happens when an oceanic plate collides with a continental one. So again, the word convergent means coming together. And these plates are going to run into each other. So let's draw a nice piece of continental crust over here on the right side of our paper. Now, if you'll remember, that continental crust is going to be way thicker than the oceanic crust. And it's also going to be less dense. So when continental crust and oceanic crust collide, so over here I'm going to draw some oceanic crust. What's going to happen is because this oceanic crust is way more dense than the continental crust, it's actually going to go under the continental crust. Okay, it's going to go way under that continental crust. Now, what's under all of this crust, by the way? We have magma. Okay, we have the mantle. And what's in there? We have magma. So down here, it's going to be hot. The piece of continental crust that gets kind of shoved under, the piece of oceanic crust that gets shoved under the continental crust is going to get very hot. What do things do when they get hot? They're going to start melting. So what's going to happen is you have pieces of this oceanic crust that are going to start melting. And again, the same thing kind of with convection. Hot liquid is going to start rising because it's less dense, so it's going to start bubbling up into this less dense continental crust. Okay, and you're going to have these little things called magma chambers. You're going to have magma chambers that are going to form within that continental crust. Okay, and again, over here, this oceanic crust is cool, but as it goes down, it's going to heat up, it's going to melt as it heats up, and then because it's going to be hotter, it's going to start bubbling into this continental crust. And what you're going to see is something that you might have heard of before. What forms up here? Eventually, we have a nice little volcano that's going to form. So yes, this is how we get volcanoes. Over here is something I want you to pay attention to. This process of this oceanic crust dipping down into underneath the continental crust has a name. This is called subduction. Notice the word part sub means under, and that's known as a subduction zone. I might want to go ahead and draw my water line to show that this is all happening under the ocean. Some good examples, a really good example of where this has occurred is actually in the United States along the Washington-Oregon coastline. We have a really cool geographic feature called the Cascade volcanoes, and you might have heard of a really famous one called Mount St. Helens. It's a volcano that has erupted before, and so what has happened is that part of the coastline, that oceanic crust, okay, in the Pacific Ocean, has actually subducted under the continental crust under Washington and Oregon right there on the coastline, and we have that chain of volcanoes. So a pretty cool thing that happens. So that's what is going to occur when oceanic and continental crust are going to run into each other. Now, what happens if all of this occurs under the ocean? Okay, and again, these are coming together. And just to remember, how does this happen? How does any movement of tectonic plates happen? Through the convection currents within the mantle. And we talked about that in the last video if you need to go back and review that. So the second thing we want to look at is what is going to happen if we have two oceanic plates coming toward each other and converging. So this would be oceanic convergent. And all of this is going to happen where? You guessed it, underwater. So let's go ahead and I'm going to draw my pretty little ocean line. So what's going to happen here is really similar to that last drawing that we did. We're going to have two pieces of oceanic crust. And again, those are going to be thin. And this other piece of oceanic crust, when they run into each other, is going to subduct underneath the first one. And the same thing is going to happen as in that last picture that we drew. Over here, it's going to be cool. And as it subducts underneath, it's going to get warmer and warmer until right under here it's going to be hot, because at this point it's in the mantle and it's hot under there. So this again is going to melt, and what is it going to make? It's going to make those little magma chambers just like in the oceanic continental example, and they are going to rise up in that oceanic crust. And now this is really thin, a thin layer, okay? Very dense, very thin oceanic crust, so it doesn't have a long way to go up through that crust. And what is that going to make? Again, we're going to have this time an underwater volcano. And this is how we end up getting islands eventually. So yes, there are volcanoes that occur underwater, and it's the same process. And don't forget, right here we have our magma chambers. These are new words that we've learned. And right here is our subduction zone. That's when that one piece of crust is shoved like right under the other one. And this is going to happen with an oceanic convergent boundary. Okay, so as this lava cools, it's going to turn into rock. And then it will eventually forms an island chain. So these island chains that we see that just pop up in the middle of the ocean in different places, they didn't just randomly pop up there. They have occurred because of these underwater volcanoes that have erupted, and this lava will erupt and it will cool and form rock, and as it keeps happening, this is going to eventually come all the way out of the water, and you'll eventually have yourself a nice little island. I'll draw it a palm tree, some coconuts. There we go. So that's eventually what you're going to happen in the future. So that was oceanic convergent coming together. And the only option we have left to discuss is going to be what happens when we have two pieces of continental crust that are going to run into each other. So this is where we're going to talk about Continental Convergent plate boundaries. Continental Convergent plate boundaries. And I think this one is really interesting because we live right in the beautiful Appalachian Mountains, and this is how our mountains were formed. And so what you have here is you have a piece of continental crust. You have a piece of continental crust, and you're going to have another piece of continental crust, and as they come together, what you're going to eventually see is that as they come together, they're going to bump into each other, and you have some overcrowding that's going to happen. And what you're going to see is you're going to see layers that have formed, and all of these different colors I'm using just show you these layers and how they're going to pile up, and you're going to see them even sideways. There are certain places that you can drive around where we live and see some of these layers where they've cut through the mountains to do mining, and if the cut through, you can see this as well. You can see where these layers that would typically be horizontal, almost vertical or diagonal at times because of the two pieces of continental crust that have run into each other, and then you have all this overcrowding, and that's where you're going to get a mountain. And that's really exciting because we live in the mountains. So we see lots of really cool examples of where this has occurred. So over here, what you're seeing are layers of deformed rock, and you're able to see, like you can even imagine when you drive by and look at this where we live, you can see how these layers how these two pieces have run into each other, and all of those layers have kind of, instead of being nice straight stacked layers, they've turned on their sides, or some of them are kind of jaggedy looking, things like that. It's really, really neat. Also over here on the flatter spots, you will often see folded rock layers that are still even horizontal, okay? So sometimes you'll even see that, and that's a good example of what you can see in the mountains that have been cut through around here. So examples of this are the Appalachians, where we live, and then also the Himalayas have formed this way. So this picture doesn't really even do this justice. This causes mountain chains, miles and miles and miles of mountain chains. So you can imagine what kind of destruction would have happened as these mountains were built. And it took a very long time for this to happen. So it wasn't like one day these two plates collided and this occurred. This takes years and years and years of collisions, of converging to create mountains such as this. So that's why I really love earth science, because we can look outside and see evidence for how all of these changes have happened. And so exactly where we live, you can look outside and see evidence for a continental convergent plate boundaries occurring, creating the mountains around us. So really, really super cool. So thank you for watching this video. Hopefully it has helped you study for the Friday quiz or the upcoming tests. Again, make sure that you're looking over these things and take time to look at the world around you and see that these mountains that we live in didn't just happen out of nowhere. Some really cool things had to occur to give us these mountains. So thanks for watching and have a very nice day.